Every year, more than 70 million metric tons of aluminum are extracted worldwide. If each ton is worth $3,000, we are talking about a $210 billion market, making it undoubtedly one of the wealthiest markets in the world. But did you know that aluminum foil comes from a rock called bauxite? If you want to see how these amounts of aluminum are extracted, join me to visit one of the largest factories in the world that make this product possible. Aluminum foil was invented in 1947 by the American company Reynolds Meadows, initially for wrapping chocolate bars. Since then, it has become a popular material in the kitchen for its durability, water resistance, and ability to keep food warm thanks to its shiny side that reflects far infrared rays. Before the 20th century, aluminum was more valuable than gold due to the complexity and cost of its extraction process from bauxite, a common mineral in the Earth's crust. Aluminum oxide extracted from bauxite is used to produce aluminum foil and beverage cans. So, how does a reddish rock become thin aluminum sheets? Stay, and let's learn about the process. Bauxite is an invaluable resource, as it is the only mineral from which aluminum can be economically extracted. Right in the heart of the majestic Australian mountain range lies the mine of the multinational Alcoa, which holds the title of the largest in the world in its category. Every year, this mine produces an astonishing amount of around 22 million tons of bauxite. However, extracting this valuable resource is no easy task. A thick underground rock barrier over 5 meters deep must be breached before the bauxite can be reached and collected. This is where the formidable excavator comes into play, capable of moving about 7,000 tons of bauxite daily. Despite all the geological challenges at this mine, the bauxite extracted from this region is particularly valuable due to its high concentration of aluminum oxide, which exceeds 50%. This mineral from the jungle is a true gem of nature, providing the fundamental element to produce aluminum, an essential material in numerous industries worldwide. Water plays a crucial role in the extraction of bauxite. The demand for water in a bauxite mine is monumental, making it non-negotiable to have a nearby water source to continue the process, as it is used in large washers to remove clay and other materials containing little aluminum from the bauxite. Then, there is the challenge of separating the aluminum and oxygen from the rest of the bauxite components, a process that involves crushing the mineral into powder, which is done thanks to large mills capable of processing more than 2,000 tons per hour. This finely ground bauxite powder is transported on cargo ships to aluminum refineries for further processing. The aluminum atom in bauxite is bonded to oxygen, and to obtain pure aluminum, these bonds must be broken through a process called electrolysis. Then, through a chemical transformation, alumina is extracted, which is later subjected to a calcination process to remove any trace of moisture. The pulverized mineral is transported to facilities like the Alcoa refinery, where this crucial process takes place. To extract aluminum oxide from bauxite, caustic soda is used in a process dating back over 100 years, known as the Bayer process. In this process, the bauxite is mixed with caustic sodium hydroxide in a pressurized solution. This mixture separates the aluminum oxide from the sludge, producing a concentrated solution of aluminum oxide. What happens next is crucial. This solution is dried and converted into a white powder known as alumina. This white powder is the starting point for a variety of applications, but its main use is in the production of metallic aluminum. For transport, the loader fills ships with up to 70,000 tons of alumina, preparing it for distribution and use in various industries. But how does a white powder become a metal? Well, the transported alumina will be transformed by a smelter into 35,000 tons of pure aluminum. But to obtain pure aluminum, it is necessary to break the oxygen atoms that hold it so tightly. The way to achieve this is by using substantial amounts of electricity. The white powder moves along a conveyor belt directly to the smelter, where it is finally transformed into pure aluminum. In this factory, there are over 430 aluminum crucibles, where a crucial process takes place. In these crucibles, intense electrical currents are applied to carry out electrolysis. The powder is introduced into furnaces, where it is submerged in a bath at a temperature of 950 degrees Celsius, well above the melting temperature of aluminum, which is 660 degrees Celsius. Inside the furnaces, a powerful current circulates, causing the aluminum particles to dissolve from the white powder. The force of the electrons breaks the bonds between the aluminum and oxygen. As a result, the oxygen rises to the top of the crucible, while the denser molten aluminum sinks to the bottom. The production of aluminum consumes 10 times more energy than the production of steel, and this energy is incorporated into the metal. Liquid aluminum is highly reactive, with its contact with water particularly feared because it releases an amount of energy comparable to a dynamite explosion. With each stage of transformation, the value of the raw material increases five-fold. Interestingly, about 1/3 of the cost of a kilogram of aluminum is due to electricity consumption, which is why it is common for aluminum processing plants to have large energy sources nearby, such as hydroelectric dams. Despite the large amount of energy required for its production, once the aluminum oxide is freed from the oxygen atoms, the resulting metallic aluminum is highly stable. This means it can be melted and reused repeatedly indefinitely. To meet demand, this operation is carried out 24 hours a day, 7 days a week, and produces more than 154,000 tons of aluminum per year. Now comes the time to extract the aluminum from one of the crucibles. How is this process carried out? Each crucible produces about 1.5 tons of aluminum per day. The crucibles full of molten aluminum are transported to the molding area. There, the liquid aluminum is poured into molds to shape into ingots, which are solid blocks of aluminum with a rectangular shape. To speed up the solidification of the molten aluminum, the molds are cooled with water. Once the aluminum has solidified, the ingots are demolded and are ready for the milling process. Each ingot is of enormous dimensions, measuring 5 meters long and 1.5 meters wide, with an impressive weight of 8 tons. Due to their large size and weight, the ingots must be handled with cranes and placed on special platforms. Then, a special machine takes care of removing impurities by shaving off a few millimeters from the thickness of the ingots. This process ensures a perfectly smooth finish, eliminating any imperfections on the surface. Finally, the aluminum ingots, now clean and smooth, are sent to the factories that produce aluminum foil. The manufacturing of aluminum foil is a meticulous process that involves the repeated thinning of a massive block of aluminum. After the initial casting phase, the rolling step, which is the second crucial phase, comes into play. Here, the aluminum ingots undergo a precise heat treatment and then pass through a series of rollers that crush and stretch them, reducing their thickness and extending their length. The temperature reaches such high levels that there is a risk of the ingot sticking to the mill rollers. To prevent this, a coolant composed of 95% water and 5% oil is used. This ensures a smooth and trouble-free process. Starting from an impressive thickness of 45 centimeters, the ingot passes through the machine between 12 and 16 times. Each rolling stage involves rollers of different sizes and shapes, resulting in increasingly thinner and more uniform aluminum sheets. The ingot, now transformed into a sheet half a centimeter thick, is ready for the next step in its metamorphosis. This sheet, thin enough to be handled precisely, is directed to the coiler, where it is rolled up on itself before being transported to the cold mill. This is where its thickness will be reduced even further. During this cold rolling process, the layers of aluminum come into contact with rollers of different textures, creating different finishes on each face of the foil. However, the sheet, now only a few millimeters thick, faces the risk of breaking due to the tension required for this process. To prevent this issue, a solution that acts as both a coolant and a sealant is used, ensuring a smooth and trouble-free lamination process. Cold rolling is essential to prevent overheating of the sheet and to protect it from potential damage. Once this step is completed, the annealing process begins. During this process, the aluminum sheets are subjected to high temperatures for a specific period to reduce their hardness and improve their malleability. This makes them more flexible and moldable, facilitating their handling and use in various applications. The aluminum sheets are cut into standard-sized sheets and rolled into rolls of different sizes, on cardboard cylindrical tubes or any other material. Once the aluminum foil has been processed, it is ready to be shipped and used in the kitchen to wrap food. Now you know all the work behind aluminum foil. Tell me, what do you think of the process? Leave your opinions in the comments. If you liked the video, click the like button and don't forget to subscribe to the channel. In the windows you'll see next, there are more videos that might catch your attention. Feel free to watch one. See you next time.